Welcome back to the morning show. It's time for more science fun, and as always, Matt Sellen, the wise guy, is joining us today. Good morning, Matt.
Good morning, Robert. Good morning, Gay.
Good morning.
So what we saw in that first part was that if something has a lot of rotational inertia, like this big wheel, it can be spinning pretty slowly and have the same amount of angular momentum as this little one when it's spinning very fast. That's why when you pull your arms in, you start to spin faster when you're a figure skater, because you have a smaller rotational inertia and then you spin faster like that one. The interesting thing about this angular momentum thing, though, is that not only does the size of it want to stay the same, the direction wants to stay the same. It has a direction. And to figure out the direction, you use what's called the right-hand rule. You curl your fingers around the way the thing is rotating, and your thumb points in the direction of the angular momentum.
Okay.
Okay, so if I get this thing spinning, it has a lot of angular momentum now pointing that way. And it wants to stay pointing that way. And in fact, that's how these gyroscopes work. Here's a little gyroscope that I can get spinning. Now, it wants to stay spinning in that direction. No matter what I do to it, it kind of still points that way.
Oh, it does.
Yeah. So that's how airplanes and so on navigate using gyroscopes, because the little spinning thing always wants to point in the same direction. Okay, so now we're going to do an experiment, and I think we're going to use you again, Robert, if that's okay.
Yeah.
If you'll sit on this stool, and what I'm going to do is get this thing spinning really fast, or as fast as I can. Then I'm going to hand it to you. Okay, so put one hand above, one hand below. Right now, this thing has angular momentum pointing up.
Right.
Now, you're going to make it try to point down. It's not going to like that, and let's see what happens. Turn it over. Well, take your feet off the... Oh. Okay, let's start over again with your... Okay. Why don't we... Okay, so let's turn it back the way it was to start with.
Okay.
Okay, now lift your feet off the thing. Now flip it over. And he starts to turn all...
Cool.
Isn't that neat? So what happens is, you made this thing's angular momentum point down, but it didn't like that because it still wants it to point up. So it makes you rotate this way. So now your angular momentum points upward.
It's like driving.
Yeah. So there you go. The more you... Now, if you do something interesting, flip it over so you get started. Flip it the other way. Oh.
So you start spinning.
Rotating.
There you go.
So now you're spinning. Let me take it, and I'm going to turn it back. I'm going to give it back to you, and you're going to flip it over again. Let's see what happens to you. You get going even faster. So every time you do that, you pick up more angular momentum this way with the way that you spin. So that's pretty cool.
I can't stop. No, I'm kidding.
That's okay. So now if you flip it over, you'll slow down. Okay. And what did you feel when you turned it over?
It kind of wants to twist in your arm.
It's hard, isn't it? It's really different from if it's not moving. It feels very different when you try to flip it over.
Like Gabriel, try with the training wheel.
So that's pretty neat. And the thing that I showed in the
Robert
shot,
stumbles around.
This is the last thing, and this is kind of hard to explain in just 1 minute, but I'll show it because it's very cool. So when I spin this thing now, it has a lot of angular momentum pointing sideways. When I hang this thing on the end, like this, it doesn't fall down. You see that? It starts to precess around. And this is a peculiar motion of a gyroscope, and it has to do with exactly the same thing that I just talked about. Okay, but I'll maybe explain that next time or something, because it's a little tricky to explain that one. But anyways, let me tell you about this weekend and next week.
Oh,
okay?
yes.
This weekend is Engineering Open House at the University of Illinois. And so that's a very, very cool thing. All day Friday and all day Saturday, anybody can go to the university, and I would suggest to go to the physics building especially, and you can see all these kinds of demonstrations.
Oh, neat.
Okay.
Mad scientists come out of the woodwork for this thing.
That's right. And to finish up real quick, the question for next week is something that can set aside men and women. Okay, this is kind of interesting. So here's what you do. You lean over, you stand with your back to the wall, you lean over, and you touch your toes, and you see how close you can get your feet to the wall before you start to fall over. And it's different for men than it is for women. In fact, women can do this better than men on average. And if you can explain why, that would be good.
Because we're women. I think he's looking for a little bit more scientific of an answer. So if you think you know the answer, go. You can email him, wiseguy@wiuc.edu. And, of course, check out the Engineering and Science Open House.